was already done. Perfect. Then we get to Bastiaan Olij's talk about the Godot game engine XR. Bastiaan has an interesting background in being born and raised in the Netherlands, but is now living in Australia. So he's also doing his talk from down under. He's the core developer for XR support for Godot, one of the maintainers of the Godot XR Tools, and he also has an interesting YouTube channel with a lot of live VR development sessions and tutorials. And with that, I will give Bastiaan the floor.
Alrighty. Hello, everybody. Thanks for having me today. Hopefully, I can have a bit of an interesting dump of information about what Godot is, what you can do with it, and what role we're playing in the XR market. I'll start with just sharing my screen. There we go. And starting this little guy. So hopefully everybody can see my screen and my slides at the moment.
Yes.
Cool. All right. Well, my first slide is actually my version of what was just on screen already. So my introduction, I'm Bastiaan Olij. I'm the lead XR developer of Godot. I was the person who started XR support in Godot about 7 years ago. I'm also one of the foundation board members. I'll talk a little bit more about the foundation later in this talk, and how the foundation fits in with the whole Godot ecosystem. As also already mentioned, I am originally from the Netherlands. I moved to Australia about 15 years ago. But when I was living in the Netherlands, I kind of began my whole career in the Dutch demo scene. For those who are aware of the demo scene, which is really my start in doing graphics programming and rendering engines and all that sort of stuff, that eventually put me on a road to be interested in XR and do XR stuff. There's also my email address at the bottom, where you can reach me if you have any further questions. Just want to run through a couple of quick things around Godot just to sort of set the stage. So Godot is a relatively new game engine. It was open sourced in 2014. Before that, developed by Juan, I can never pronounce his last name, Linsensky and Ariel Mansour. Actually has a history going back at least a decade more, where they worked on several private engines for their own game projects and game projects that they supported in Argentina, but then in 2014 decided to open source the engine. So coming back to today, we have a fairly sizable community that is growing almost exponentially. We've had a big growth spurt at the end of last year, so you can see that almost some of these numbers nearly doubling since the year before, and we're, as a result, also seeing more and more games coming out with the engine. What we're also seeing more and more is people making applications with Godot, whether it is in support of game development, like Material Maker is a good example, which is a what's that thing called, where you can create all the texture materials, Surface, I think it is. But it's an open source competitor of that sort of software, which is made in Godot. Here are a couple of examples of some of the bigger known games that came out last year or the year before. Sonic Colors is on here as a bit of a interesting version, because Sonic used Godot as a base, but build a whole bunch of custom stuff on top of it. But it's still a very good example of what a AAA studio can do with Godot, and how nice it is that you can take an open source engine and customize it to your needs. All the other examples here are fully made in Godot. Cassette Beast came out not that long ago, big hit game. Brotato is one of our best sellers. Cruelty Squad is a nice one on here, because that actually has a VR mod nowadays, so you can play that game in VR. I'm not sure if I would recommend it though, because it's very high-paced and very nauseating experience, but still a very cool thing to see. We had the news break, I think a week or two ago, that Slay the Spire 2 is now officially in development and being made with Godot, or Slay the Spire 1 being an incredibly successful indie game originally made with Unity. So yeah, there's lots and lots of cool things coming out. On the VR and AR side, we don't have a lot to really show, because there's still not many games that really hit the limelight. We know that there's a bunch of things that are being made on the business side, things that we see less publicity for, unfortunately. And it also touches on one really important thing with Godot, because it's open source, because it's freely available. There's obviously also no requirement for someone using Godot to let us know that they're building something with Godot. So there is a sense of there's more out there than that we are aware of. But that's always a bit of a juggle. If you do want to look at some VR games that are being made with Godot, good examples are the port of Friday Night Funkin' to VR. There's a really good VR port out there that was actually made with Godot 3. There is a game called, now it's slipping my mind. Dang it. I hate it when I forget names of games. I should have put a note down. But there's a little little match shooting game that's out. And if I remember the name, I'll mention it later on. But it's escaping me right now. But there's a bunch of games that are on App Lab that are made with Godot. It's just we don't have a full list of that. Kind of already alluded to this, Godot is very heavily used by independent developers. Most of the titles that I showed on the previous slide are made by indie devs, and we really see that in the participation in game jams and where Godot is being used in those areas. And as this nice little overview said, the game jam GMTK is one of the biggest game jams around, and while Unity is still taking the crown, we're a good second. So you can really see that the engine is getting more and more popular. There's also more and more things. Well, actually, we are one of the biggest engines on itch.io. So again, a sign of our our popularity within the indie developer culture. So what is Godot? A game engine is the short of it. We are a full-fledged game engine that does both 2D and 3D, and not named particularly here, but nowadays also XR. One of the nice things about the engine for those who are using it is that it is a separate implementation for 2D and 3D, while many of the other game engines sort of do a pseudo 2D. Not really that interesting for AR and VR developers, but it is a nice thing to know. We do very nice UI things as a result, which are, they have a lot less overhead than if you're using a 3D engine to do that sort of things. It has a very powerful IDE. Everything you can do is integrated in there. You can use a lot of, separate components, like there's people who want to code in, say, VS Code instead of inside of the EDA. So there are links between them that you can build, but you don't have to. And we'll show that in the demo later on today. I'm going to be doing everything in the Godot EDA. I'm not going to be leaving that. It's also a very tiny game engine. It's 40 MB is a bit misleading. It's almost 50 MB now. It's grown a little bit over the last year, but still, it's a very small download. And as an open source game engine, it is also completely free. Godot is based around its own scripting language. The Godot itself is built in C++, but we have a scripting language called GDScript that you can use to build applications with or games with. However, since a couple of years now, we have an extension layer called GD Extensions that allows us to also incorporate languages like C#, C++ itself, Swift, Rust, And Swift is a nice one to name here because the Swift integration in Godot has, for instance, been used to get Godot running on an Apple Vision Pro, which is a really nice project that two brothers, I think, from America, if I remember correctly, are working on, and yeah, that's all up and running, and people are playing around with that, which is kind of cool. This is one of the things that we are most proud of, is that Godot is really a platform that runs everywhere. So it runs on macOS, runs on Linux, runs on Windows, runs on all popular mobile platforms. You can even run it in a browser, although there are limits to running in the browser. Where we have a little asterisk is obviously when we're dealing with console deployment, where we are restricted by some of the proprietary libraries and NDAs and all those sort of things that that these platforms require for developing on them. But that is then offered through third parties who can adhere to those rules and regulations. For us, of course, in the XR market, that's really not important. Greatly thanks to OpenXR, development for XR is not tied into any proprietary libraries or anything like that. So that's the last point on this page. Is we support OpenXR in the core, and as a result, we are supporting basically every headset that runs on SteamVR. We're obviously supporting all the Meta Quest headsets, HTC, Pico, Lynx R1. Tilt 5 is then supported through their own SDK, but we have drivers for them. And there's many other headsets that in theory should work. We are limited to what we can test. So if you are on a headset that has OpenXR support and you want to use Godot on it, there's a good likelihood that it will work. But if not, then it's something that we're always interested in hearing and helping out and getting it up and running, because usually there are fairly simple things that need to be done to get another headset up and running, because usually it's just a missing library or something like that.
Bastiaan, short question in the chat, maybe related to platform compatibility. Casper and Marcus ask about, is there no Unreal Engine being used in Game Jam? And is that related to platform support or not?
Unreal is definitely used in the Game Jams, but they are, for some reason, Unreal usually has a fairly small turnout on these sort of Game Jams, and they're, I don't know if I can quickly go back to, they're usually in the other section. So yeah, that's sort of our experience, and I think that has to do with the fact that Unreal has the bar that much higher, that it's people tend to choose Unity and Godot and engines like that just because it's easier and faster to get something up and running and started. But Unreal is definitely used in Game Jams. It's just, for some reason, not as popular as Unity and Godot, even though it's an amazing engine and amazing games are being made with it. So yeah, they're not quite sure what is behind that, but yeah, that's the numbers that we have. Okay, does that answer it?
Yeah, thank you.
Cool. So our mission. So this is really getting to the whole fact that Godot is an open source engine. So as I said in the beginning, Juan and Ariel were working on their own engines for their own projects. They were actually selling those engines in Argentina. There's a whole bunch of games that were made in Argentina that were made with their engines. They both kind of went down the consulting path, weren't really that busy with trying to get their engine marketed, and at some point in 2014 decided that a better path would be to open source the engine and see if they could build a community that would bring the engine further. And the rest is kind of history. That I think that neither of them expected the success that the engine would have had, and it very quickly got to a point where Juan could work nearly full time on the engine, and then in the last 5, 6 years, the engine has really grown in popularity. It's MIT licensed, which is very important. This is something where a lot of people struggle with, because when they hear open source, a lot of people think of GPL, which obviously means that if you build something with an open source piece of software, you need to open source your software as well. With MIT, you have no such restrictions. It really is, here's the source code, and as long as you let, put somewhere in your game or in the thing that you make with it, that you've made it with Godot, either by just including the license text somewhere, or that's really the only requirement I think that we have. You can use the software any way you want it. You can modify it to your heart's content. You can really do whatever you want with it, and that was a really important thing for us, that we, back then for Juan, but I think we've all adopted that philosophy. That this really needed to be a game engine that was as open as possible, that everybody could just pick up and do with whatever they want. And it also means that obviously, you can take this engine and make your own engine out of it, and go and develop it in a completely different direction than what we do. For someone choosing Godot, that's obviously on one side a risk, because you're suddenly going like, hey, I've got this open source engine, how can I ensure that I'm being supported? There's just this bunch of hobbyists working on it, which was kind of true 10 years ago, when it was open sourced. Now, 10 years later, we're really in a position where there's such a big ecosystem around it, with a number of professional service companies that offer paid support, and have a whole bunch of experienced Godot developers and staff. It's really coming into its own in that way. We're not Blender/Linux level open source yet, but that is obviously the longer term goal, that we want to be, have sizes of communities in comparable to a project like Blender. Something that we are very, very big in is to make sure that Godot uses only open standards wherever possible. We do support some closed standards like FBX, and obviously some of the operating systems you could see as closed. But we try to do as many things with open source as we can. So Godot is a Vulkan engine with an OpenGL ES fallback. We do have DirectX support nowadays, and Metal support is around the corner, but Vulkan and OpenGL are the cornerstone technologies that we use render-wise. Similarly, WebGL is fully supported. WebGPU is coming. That's also one of the things that we are working on. Well, OpenXR, what do I need to say? That is obviously the heart of the technology that we're going to be using in XR. And yeah, the whole point of Godot is that it is an open source project. The development process is fully open. Everything's community driven. You can see everything that we're doing on our GitHub page. All our social medias are open to people. We have a Rocket Chat server for people who actually want to contribute to the engine. We have a very popular Discord server where our community is discussing, from a user point of view, and where you can go for help. There's an incredibly active XR channel on the Discord server, which is really cool. So yeah, it's all about having a game engine that everybody can look at, everybody can help out with, everybody can have a say in where this is going and sort of developing it. The other thing which is really important to us is inclusion. I know that this can be a hot topic for some people. We are a community that is global. We have people from literally all countries of the world using Godot, contributing to Godot, and something that we really stand for is inclusion there. So there's a lot of people from the LGBTQ community who are happily in our midst, and that we try to support as much as possible. We have a lot of people in third world countries choosing Godot because of its lightweight and ease of starting into it, and the fact that it's free. So yeah, there's a whole bunch there, and hopefully that also means that we can really open up XR development to as many people from all walks of life. So yeah, that is a very important thing for us. Okay, a little bit about the Godot Foundation. So Godot open source, the source code is on GitHub, but it needs to be managed somehow. You can't just have thousands of people show up and just merge in whatever changes they want. There has to be an organization that overlooks everything and tries to guide that process. And that organization is the Godot Foundation. So originally, when Godot was open sourced, Godot was put under the umbrella of the SFC, the Software Foundation Conservatory, if I remember correctly, SFC stands for. So that's an organization in America that overlooks a whole bunch of smaller open source projects and manages their finances and makes sure that everything is above water and that we play by the rules, basically, and that we're not just taking donations and running away with the money. We became too big for them at some point in time. We had demands and needs that they couldn't keep up with. Or I'm saying it a little bit darker than it was. They really helped us a lot, but it was just clear that we had a demand on them that kind of outgrew them, and we decided to take that to ourselves. So I think about 1.5 years ago now, the Godot Foundation was established. It is, interestingly enough, a Dutch stichting. So for all the Netherlands people in this session, we'll be glad to hear that yes, Godot is Dutch in a way now. So the Godot Foundation was established in Holland as a not-for-profit organization, the Godot Foundation oversees all the financial sides of the Godot project. So we take in donations through our funding platform. We take sponsorships from bigger companies, and we then do something with that money. And obviously, what do we do with that money? A lot of things. Our current focus is really on looking at what the parts of the engine are where we aren't finding natural contributions, and we are finding contributors who want to work on that and who we can hire and pay for that work, so that we can make sure that those things are done. We are involved in sponsoring Godot events. So obviously we had GDC not that long ago that was heavily sponsored by W4 Games, but also from the foundation. We obviously make sure that both developers and foundation members can attend, so we do that. We had GodotCon a couple of months ago, so that is something that we organize and we obviously use the funds for. But we're slowly moving the goalpost a little bit when it comes to using this and trying to really build up a more supportive top end of the project. So we've now hired a communication manager who looks after all our social media. We've hired a web developer to look after the website. So really those sort of things, the more administrative things and all that sort of jazz, we're trying to use the money to do that, so that we don't rely too much on people just volunteering their time and actually rewarding them a little bit for all the hard work that people do, and then leaving it up to those people who are making games with Godot or making XR projects with Godot or making their money with Godot, having them upstream some of their work and fixes and time and moving the project forward in that way. So yeah, this is our call to arms, so to speak. That's the whole mission of Godot, what we're about, what we want, and obviously we hope that besides people wanting to pick up Godot, is also help us out with keeping us alive, basically. So now for the things that really are interesting for everybody who joined today. What can Godot offer you when you are an XR developer? So just to start, this is, by the way, a screenshot of Friday Night's Funking VR, which is an incredibly fun game to play. It's already a somewhat older game that was made with Godot. So yeah, like I said, I started about probably about 8 years now, with adding XR support in Godot, there was a lot of demand from the community to do this, but no time from the core team to invest in that. And I had an interest in this stuff, so I really kicked it off, starting with OpenVR, eventually adding VR API support for back then the Oculus Rift, eventually growing the team, getting other members in that allowed us to focus on the Quest. We had a couple of years where Meta invested some money in us to make sure that the Quest was well supported, and then as part of that also they enabled us to make the switch to OpenXR, and we actually decided before in Godot 3 everything was run by plugins, but in Godot 4, our current version, when we chose to make sure that OpenXR worked properly, we actually brought it into the core. So it's no longer a plugin. It has, out-of-the-box support for OpenXR. Some of the other platforms like Tilt 5 do require plugins, but OpenXR is supported in the core. So you just download, and we'll see that in a minute. You just download Godot, and you have OpenXR functionality. For Android, there is a small plugin needed because of all the different loaders that the different headsets have, and we've moved some of the vendor-specific logic into that plugin. But that's really specific to Android. So yeah, as I mentioned, plugins structure that allows us to also support headsets like the Tilt 5. I'm struggling to think of another example of that. I think Tilt 5 is really the only one right now that requires a plugin to run. And I already mentioned about the Android OpenXR loader additions that we need. So the core of Godot provides all the necessary functionality to make XR work, but when we are looking at higher level logic like teleporting logic or movement logic or interaction logic, that's where we use different parts of the engine together, and for that we have a couple of libraries, or actually just one big library called the Godot XR Tools library that we put together to basically offer a whole bunch of out-of-the-box functionality that you can use in your project. You don't have to use that. There's a lot of documentation that we have to show how it works internally if you want to do your own thing. Also, XR Tools is really focused on VR functionality. So for AR, there is still some ways to go before we have a good toolkit for people to use. However, it's really easy to work with, so it's generally for a lot of people not a huge problem that they need to do a little bit of extra work to build those things up. For those people who use C#, that's the other very popular language that many people use with Godot. There are a few other toolkits that implement all the same logic in C#. So, and the same thing, and I might show that in a minute before we start on the demo itself. On most of the documentation in Godot, we actually have all examples both in GDScript and in C# so that you can look at what you need to do there. Godot has a growing XR community, including a growing number of people who are contributing to the XR support in Godot. The main place that we hang out is on the official Discord server in Godot. And we have a nice channel there that's on the screen here, the XR channel, and it's a really busy place. There are a lot of posts daily. 50 plus is a bit of an average. I've woken up in mornings with well over 100 posts that I need to catch up on, and yeah, when it's been a busy day. One of the things that's really nice about the Discord as well is that some of the people, indie developers do like to kind of share what they're working on. So we have a number of people who have recently switched from Unity to Godot and are porting their VR application to Godot, and who are posting about their whole journey there. On the screen here is Z, who's doing a really cute little penguin game, and that's starting to look really interesting. The other one, which is really interesting, which unfortunately I can't show yet because it's happening this week. There's another team that are working on a Godot game who are doing VR and AR on the side, and they're currently participating in the hackathon that Meta is organizing in Los Angeles. And hopefully next week we'll have some things to share about what they've actually built. But they're actually using the current beta version of Godot with all the new functionality that we're working on for AR. They're making an AR game that they're competing in the hackathon with, which is really interesting. We have a number of YouTube channels from different contributors who are doing tutorials. I'm only one of them. In the introduction. Obviously, you can see the link to my YouTube channel. I'm mostly doing streams nowadays. I want to go back to doing more tutorials. But Malcolm, who is the other developer who is working on XR Tools, he posts a lot of tutorials on what he's doing. David Snowpack is another developer in the Godot ecosystem that is interesting to follow. He does regular streams and tutorials on his YouTube channel. Mostly focused on WebXR, but he is now doing more AR things as well. So yeah, there's quite a few interesting people to follow if you want to learn more about how things work and how things are going. So this is the state of affairs at the moment. So our current release is 4.2. It's also the version that we will be using today for the demo. And 4.2 is a version that does have some limits when it comes to AR. We have been mostly in Engine focusing on VR. But the upcoming Godot 4.3 version that is currently in development has seen a lot of development on the AR front. So we've just finished work on supporting the Meta Scene API. So that is if you have a quest where you can scan your room and you can bring in all the elements that have been found there. So you know where your table is, you know where your walls are, all that sort of stuff. So that's now up and running. That's now in testing. We're bringing in support for anchors so that you can anchor, a virtual screen somewhere, or you can hang up something on your wall, or you can put some things on your desk, including persistence anchors, so that when you shut your quest down and come back the next day, everything is back in place when you start your Godot experience. And again, that's also what the guys who are currently at the hackathon are all using and playing around with. We have a whole suite of new functionality around eye tracking, face tracking, hand tracking, body tracking. 4.2 has a lot of hand tracking, but it's still a bit iffy. But in 4.3, we're really tightening that up. So that should really be solid, because for AR, that is obviously really important to make sure that you can interact with the things around you with your hands. Then the last two are just more general things. We're doing a whole bunch of improvements around foveated rendering, already supported in the 4.2, but we're tightening things up. Same with MSAA. That is actually a missing feature for 4.2 when it comes to the OpenGL renderer, which we'll be using today. But that's all coming in 4.3. 4.3 is about to go into feature freeze, which means that we stop adding new features to it, and we're going to spend a month to a month and a half just tightening up everything. And the expectation is for a release within 2 months. But obviously, that all depends on what we find and what issues we need to solve. The 4.3 is going to be released relatively soon. Excuse me? Someone tried to say something? Was up accident. Okay, last slide on the slide deck is just if you want to have general information, or contact Godot Engine, or want to know about helping out. This is the general contact email address for the organization, and the URL to the website. Where you can find a whole bunch more information about what the engine is. So that's as far as the slides that I have today. So I want to start on a demo in a minute, but before we get there, I was wondering if there are any questions so far.
Yeah, I'm not sure you can hear when my Teams keeps crashing, and I've already switched to my laptop and it crashes there. Anyways, I was about to say that there were 2 questions on 4.3 in the chat. Wilco asked Will it support OpenXR 1.1?
I think 1.1 is going to be a 4.4 thing. We do want to switch to 1.1 very quickly, but because we're already nearing the cutoff date where we're going to go in feature freeze, it's unlikely that we are going to include OpenXR 1.1 in this particular release. But it's very likely going to be 4.4 because we want to switch over really quickly.
Okay. The second question is from Dylan. Will variable rate shading be supported in VR?
So variable rate shading is already supported in on the Vulkan renderer, but we are tightening that up a lot in the 4.3 release. For the OpenGL renderer, we're truly piggybacking on the foveated rendering support in OpenXR itself, while for the Vulkan renderer, we're doing mostly everything ourselves through the VRS extensions in Vulkan. I would say an 80% yes on that one. There are some things that we need to tighten up, but we do have support for that in the engine.
All right. Any more questions before we go into the demo? If not, then I guess you can, can go on.
Okay. So first thing I wanted to quickly go past is our website. GodotEngine.org, that's where you find us, and you can find lots more information about us. But the most important thing is that is also where you find the download link for the latest version. Now, obviously, I downloaded this already, so I'm not going to do that right now. But we will go and start it up. So when you start up Godot, you get this beautiful little thing called the project manager. I nicely cleaned it out for today, so it's asking me like, hey, you don't have anything, do you want to bring in some demos, which I don't in this case. We are going to start with a brand new little project, and I'm just going to go and create that in Godot star. No, just do demo. And I want to do Godot XR demo create folder. That was supposed to, oh, that's because that one doesn't exist. Okay, my mistake. Create folder. There we go. That's happy. So that's just setting up a project, and then we get the choice between 3 renderers that we have available to us. The first two, Forward Plus and Mobile, are Vulkan renderers, where Forward Plus is our advanced, compare it to Unity's high definition renderer, where we've got lots of nice little, beautiful features with all sorts of stuff like SSAO and SDFGI is added in there, and it's a high-end renderer that allows you to get pretty realistic graphics. However, won't run on a Quest. It's a little overpowering for a Quest. But for desktop VR, it is definitely something that supports VR. And that you can play around with. The second option is Mobile, which is also a Vulkan-based renderer. This one is still under development. There are still some rough edges to it. Once those are solved, that would be the most likely choice to use if you want to create a AR or VR experience that you're planning to deploy both to desktop devices, so PC VR, or to Android-based devices. For the demo today, we're going to use the compatibility renderer. That's an OpenGL backend. Like I said in the slides, there are a bunch of things still missing in 4.2 that we've added in 4.3 on the quality side of life. But for our intents and purposes today, it's going to be more than what we need. And that's what currently we are recommending everybody to use. So all the projects that are that you mostly see if you're on the Discord, or if you look at the things that have already been released, are mostly made with the compatibility renderer. So we're just going create and edit.
There's a question from Wilco who asks,
yes.
What do you recommend for car development, Win64 or Mono_Win64?
So the mono download is the version that has C# support. So I'm doing the non-mono one because I'm just going to be using GDScript. We do have plans at some point to just have one download so that you don't need a special version to have C# support. But that is on the horizon right now. That you do need to have the separate version. So yeah, this is just the normal. And just to go back here. So yeah, just the normal version. So yeah, the mono version is the .NET download. I'm always running on 64-bit. There's really no reason nowadays to run on 32-bit. The other thing which I forgot to say, but which is really important to note, is I'm obviously developing on Windows. But you can develop on Linux and Mac just the same. The only thing that you have to obviously keep in mind is that Windows is the platform where most headsets are best supported. So obviously, we can go through SteamVR here. We can go through the Oculus runtime. I've been playing around with Vario lately, which is obviously a very nice headset to play around with. When you go to Linux or Mac, you're a little bit more limited on those. Mac currently, we don't have any PC VR headsets that you can use there, to my knowledge. I do think that Monado is busy on eventually supporting Mac properly. On Linux, there is a wider amount of options. SteamVR obviously works on Linux for their Index headset. Monado is a popular runtime on Linux that supports a whole bunch of headsets. And there are a number of other third-party options that allow us to use Android headsets for streaming, for instance. And the reason that I'm saying that is, for me, in my perspective, Windows is the best platform for development because of that reason. But Linux is a very good option as well. I do know a lot of people who do VR development on Mac with Godot and are solely targeting Android devices. So we'll get into that in the demo a little bit later. But we can publish games directly to the Quest from the Godot EDA, so you can design your Godot XR experience on a Mac and then just push it out to a Quest and run it on the Quest and test it. And in that way, we support all three of those platforms. But for speed of development, the nice thing about Windows, and I am going to be using a Quest today, so but I'll start off with you running the Quest in Oculus Link mode to turn it into a PC VR headset, because the iteration speed is much faster, seeing that we don't have to build an APK and push the APK out to the headset. So that's the consideration between the different platforms. But yeah, just download and start with the 64-bit Godot version, non-.NET, non-mono version, just the plain vanilla version, and get the version for your platform, and you can develop on Windows, Mac, or Linux with those restrictions that I just mentioned. So I hope that answers the question that was outstanding. So in the EDA, this is where we start. We just have a blank environment. Everything in Godot revolves around what we call scenes. And for people who come from the Unity world, think of scenes as prefabs. I don't really know what the best comparison for Unreal is, but scenes is the organizational model that we build. And scenes work as a node tree. So we'll be adding nodes together to build our thing. So I'm starting with just a new node 3D, which is just a placeholder that doesn't really do anything. It's just something that I can move around in 3D space, but we're not going to do anything specific with that root. But I am going to rename it to main. That's just something that I tend to do, and I'm going to start with saving it, which just makes my life a little bit easier. Save often, I always say. Now, the thing is, if I would run this, nothing would happen because I've not set up anything. So we need to do a little bit of boilerplate, but luckily Godot really helps us in setting up that boilerplate. And the first thing that we need to do is, when we look at our nice 3D editor, we are seeing a nice sky in the background. and we actually have a sun in the sky as well. But these are added by the editor so that I can see what I'm building in my scene. The moment that I would run this, they're gone. I need to actually have them in my project as well. And Godot has this nice little 3-dot thingy here, and we can just press on the add the sun to scene and add environment to scene, and it will add the environment and light that are standard in our scene to, or sorry, standard in our editor to our scene, and we can now start doing something with that. I'm just going to leave them alone. We will deal with that later. Then we need to do a little bit of housekeeping for the XR side. So if we search for XR, we're going to find a number of XR nodes in here. And the one that we always need in every project is this node called the XR Origin 3D node. And this node maps the center of your play space, so your boundary, or depending on the mode that we set up in our in our XR runtime, it maps that center of the play space, so that the start of your tracking or whatever is used by the XR runtime to a location in our virtual space. So for AR, generally we leave that in the center and we don't really do anything with that anymore. But in VR, moving the origin point around allows us to virtually move our character through our world without the player actually physically moving. The second thing that we always need is a camera. So we're going to add an XR camera node to this. I like to always position this a little bit. So I'm going to move that up a little bit, but this position is going to be overridden by the tracking system. So the moment that we start running our VR application or our AR application, the tracking of the XR runtime is going to take over, and it's going to position that camera wherever my head is in relation to that center of our tracking space. But yeah, like I said, I do like to position it in my scene just to not have everything just sitting at the bottom of my scene. There we go. We have a camera. The next thing that I need to do, almost forgot, is that I need to go into project settings and I need to scroll down. And then in the XR setup here, I need to do two things. First, I need to enable OpenXR. That is going to make sure that OpenXR runs. There's a couple of other options that I want to set here. So I want to put my foveation level on high and dynamic. That means that my foveation level is going to be automatically applied to the most optimal. The rest I'm pretty much leaving on detail. We are not using eye gazing. We're probably going to be using hand tracking later on in this this demonstration. So I'm just going to leave those all on default. The other thing that I need to do is in this place where it says shaders, is I just need to enable the shaders that Godot needs for XR support. That option is actually going to disappear. Might not happen in 4.3, but definitely in 4.4, because we're now able to automatically detect that we need these special XR shaders when we are making XR projects. But in the current version, we need to manually turn them on. Now, I really hope that it saved everything. Yes, it did. Perfect. So with these things set up, there's one more thing to do before we have the bare minimum, and that is we need to add a script. And I'm going to create that on my main node, but I could create it in other places as well. But for what we're doing right now, it's easiest just to put it on the root. That adds a script in our GDScript language to that node. Every node can have a script, and you can have, you can define your behavior of that node, but also every node, gets called at specific times. And one of the most important one right now for us is this function that it already creates by default, which is the _ready function. So this is called the moment that our scene finishes loading. So Godot starts, loads up this starting scene, and it then calls ready on every node that has a script. And what we're going to have to do here is a couple of lines of code. The first one being, actually, I will cast that to OpenXR interface. I need to ask for, we have this all documented, and I'll show the documentation in a moment. I completely forgot about that. But I've done this so many times, I've memorized it. But I'm going to find our OpenXR interface, I'm going to check if I successfully found that, and I'm going to check if that was successfully initialized. And if that is true, I need to find the viewport that we're currently using. The viewports are the render targets in Godot. We always have one, which is the main one that we use, but we can create additional ones, and that's how you are able to send different output to the screen and different output to the headset. But for now, we're just going to keep it as simple as possible. We're just going to grab that main viewport, and we're going to tell that viewport that viewport needs to be in the XR mode. And that is the bare minimum of code that you need to get up and running. I could run it right now, but I'm going to add one more thing in here just to make it a little bit more visually appealing. And that is that I'm going to add my two controller nodes. I'm going to add my hands. So I'm going to add a node for the left hand, and I'm going to add a node for the right hand. And then the left hand, I'm going to say, well, that needs to track the position of my left hand. I'm just going to leave that on default. That's fine. And then on the right hand, obviously, I need to link that to the right hand. And again, the same thing with my camera. I'd like to give these a default position just so that they're not all on the ground. But the tracking system is going to take over and actually position these where my controllers are, or where my hands are, depending on what mode I am in. And right now, these are invisible. There are just points in space. So I'm just going to really quickly add in a mesh. And I want to have a box mesh there. And I don't want that to be that big. I want that to be smaller. There we go. Just a little cube. And obviously, we don't want to have that cube there forever. It's just a placeholder. Just again, I'm trying to get as quickly as possible through the bare minimum of getting this to work. And that should, in theory, be everything to have a really basic setup. Now, before we run this, I do need to turn my Quest into link mode. So bear with me while I start that up. Well, are we going to see that I'm using my controller? Oh, I'm obscuring the sensors, am I not? Come on. Why don't you want to use my... Okay, my Quest is being very difficult right now. It's not seeing my controller. Why is it not seeing my controller? Okay, it's seeing this one. And now it's seeing this one. So it's just being slow today. Okay, Quest link. I'm just going to start that. Launch. Yeah, my boundary is good. Confirm. Okay. Cool. Yeah, that's fine. So I've got my my Oculus running in link mode. That is right. I'm in 4.2. That option isn't in 4.2 yet. Okie dokie. Then I need to do one more extra thing before we can do this. So bear with me. I was hoping to skip this. What? I need to make sure that this is my default OpenXR runtime. So hopefully that does it, because else it was going to start SteamVR. I don't want to start SteamVR. So in 4.3, we actually have a drop-down list in Godot, which is why I got confused for a second. There we go. In 4.3, we have a drop-down list on the right top side where the choice of renderer is. There's another drop-down list here that allows us to select which runtime I want to use. So I can switch between the Meta Quest Link runtime or OpenXR or anything like that. So in theory, that should now run. Oh yeah, I need to select the current. There we go. Let's see if that wants to work. And you guys should be able to see on screen what I'm seeing. So if I grab my controller, then yeah, there we go. I can move my hand around, and Quest is very hunky-dory and happy. So hold on for a sec. Just want to make sure that it's doing what yeah, so that's the right one. And obviously it switches between hand tracking and and controller tracking. And there's a little bit more that we need to do to allow hand tracking as well. But I just wanted to show how quickly you can get the basics up and running. So this is the bare minimum to get a VR project to work. And basically this is your boilerplate from where you start to do more. So the next thing that I want to do with this, actually, I'll pause for a second if there's any questions already in being asked at this point, or if anybody already wants to ask some questions about this first part.
I have a question, Bastiaan.
Yes.
It's not necessarily about the XR part, but it does influence it a lot. I can imagine that there is a balance between like adding more programming language so people that are familiar with those can use them. But I can also imagine that adding more of them also makes it more difficult to implement new features and slow everything down. How do you feel that that balance is currently handled?
That's a really good question, and that's actually something that is actively being discussed within the team. There's two parts to that. One is where there really isn't a good way to prevent that certain things need to be done in code, like that little bit of startup script. And I actually wanted to go here before. Is that on the Godot website there is actually a bit of documentation around XR. Including the instructions for setting up XR, and I'm actually going to go to a little peek to go ahead because it's latest, sorry, because I actually want to go to the 4.3 version of this, and that actually has a new page here called a Better XR Start script. So here it explains a script that you can actually download in full that has a whole bunch of code that does all the different little bits of startup that you can do. So for instance, selecting the refresh rate, obviously with the Quest, you can run this on 72 Hertz, 90 Hertz, 120 Hertz, and I think there's a fourth option. This is the code. If you don't add this code, it's just going to run at its default rate, which is actually determined by whether you tell the Quest OS whether you support Quest 1, Quest 2, and Quest 3. So if you support Quest 1, it's going to default to 72. If you say I'm only supporting Quest 2 and Quest 3, I think the default is 90 Hertz. So if you don't include this code, it's just going to run at 90 Hertz. If you do include this code, or look at how this works and implement your own version of this, you can determine at what rate your head, or what refresh rate your headset is going to run. So those are the sort of things that really need to be done in code. We can't really avoid that. Also, just like I said before, we have both C# and GT scripts versions of that. But there are other parts where this code is then, for instance, already made available through, let's say, the XR Tools library or some of the demo projects that we have. Or when we are looking at things like, for instance, the Scene API, where we don't want everybody to write that same boilerplate over and over and over again. And we actually have put as much of it as possible inside the nodes that we add for that part of the API. So for instance, when we look at our controllers, we did not write a single line of code to make sure that our hands are positioned in the right place. The same for our camera. Everything is just knowing which nodes you need to use and then setting up the nodes correctly. So there's a balance. There's some things that you just have to do for code because they're specific to your application or specific to your needs, and there are things that we try and embed as much as we can into the nodes that we make available, so that you don't have to reinvent the wheel, basically.
Yeah, thanks. And one small addition, what do you think is the advantage, for example, of using GD script instead of just switching to C# for everything?
That is the million-dollar question in many ways, and I think the answer to that question is different for every person. Obviously, what you're used to is a really big one. If you have worked in C# your whole life, probably if you're starting in C# will remove some of the learning curve in switching over to Godot. I'm a C++ programmer for many years. So when I started with Godot, obviously with the idea of adding XR support, I'm doing a lot of things in C++ in the core engine, and I ended up learning GD script, and I really like the language because for what you are doing with your application, it's a very to the point language. Now, the one thing that I will say where I think that GD script stands above any other language option in Godot is the level of integration that it has in the EDA, and especially the fact that it just works the moment that you hit play. There's no compilation that is needed. There's no extra work that is needed. So your iteration speed, and especially once you start debugging, so I can put a breakpoint here, just the normal sort of stuff. I can do a breakpoint here, and I can step through this with F10. But what you can't do, as far as I know, in C#, but what you can do here is if I suddenly decide that I want to do something more here, and I then say, well, keep running, then I should see, oh, I do not see my print in there. Why do I not see my print in there? That should be doing that. I'm gonna make myself a liar now. So I'll get my breakpoint. If I now add in print, maybe I just didn't hit save, that's possible. Let's actually go and step over it and see if it actually reaches my, oh, it steps over it. Okay, I made a liar, that should work. Maybe because I've added into a, well, I'm making a liar of myself here, but there are a number of things that you can change while you are running through the code. And that's actually the first time that I've seen it skip over that. So caught me with my pants down there. However, the point does stand up, and at least in my experience, iterating over your code and testing is so much faster because, well, you could see how quickly, because I'm still in runtime. I had to go debug, continue there. But you can see how quickly it starts up and is up and running. And actually, the main thing right now is we're waiting for OpenGL. There we go. So that delay was because the headset had gone to sleep. I just want to see. Yeah, see, now it goes to normal speed. So yeah, don't let your headsets go to sleep. So yeah, you can see that the iteration speed becomes really fast because you can just run, change, run, change, run, change. While if you use C#, there's always a compilation step in between, and you get a delay. This is also the same issue that Mac users have when they are running natively on the Quest. That they have to go through that whole process every time that they run, which we'll see in a minute, where we actually have to build the APK and push the APK out to the headset to actually run on the headset itself. So any more questions for where we are right now? Cool. All right, so the next step that I want to do is take the project as we have it right now and start running it on the headset so that we can do a few things that are unique to when you're running on the Quest, or the sort of things that the Quest is really good for. And unfortunately, we have to do 2 steps in order to make that work. And bear with me because this is the one thing that I did not do because I just downloaded 4.2.2. I was using 4.2.1 before that. But I need to go to Manage Export Templates, and it's nicely already tells me like, hey, your templates are missing, and you just hit the download and install, and that is going to download the templates from our website and install them. So the templates are for whenever you want to do exports. You also need those if you, for instance, want you're finished with your game, you now want to export it to Windows. The exporter basically builds an exe for you, and you can distribute that to your users. But for us, of course, if we want to go and run on the Quest, we have to build an Android build of our application, and for that we need the templates that contain all the Android logic. Now, in this case, also, we are very proud of our editor only being a 40/50 megabyte download, and you have your whole editor up and running. Unzipped, it's about 100 megabytes, so very tiny. And as I just showed, you can build the whole XR application with that. But if you want to deploy it, or if you want to run it on the Quest, you do have this extra 800 megabyte download to get all your templates. Now, we're not going to be using all of them, obviously, because this now includes our Linux template and our Mac template and our web template, and any distribution platform that we support out of the box is now being downloaded. But yeah, obviously take the 15 megabyte download with a grain of salt. It's nowhere near what the other engines are, which are often multiple gigabytes of stuff that you need to download and install.
Templates, the Android tooling as well.
Sorry?
Like ADB. The templates, do they contain the Android tooling as well?
No, so that's the other thing that obviously you need to do is you do need to install Android Studio, and it's actually all explained in the deploying to Android on here. So we need to have OpenJDK installed. We need to have Android Studio installed. We need to make sure that we have a debug key. And all these things I've already got set up, so we're kind of skipping over that in here. Some more information there, and then here it steps through the specific steps that we will be doing in a minute around deploying an actual Android XR project. But yeah, so there's a little bit more there too, and that's obviously we can't just suddenly distribute things that are proprietary from Google or Meta or whatever. You have to download those things. Anyway, that's our templates installed. The second thing that we need to do is actually go to our asset library, and we're going to search for OpenXR. That's the old one. That's the new one. So we need this one, the Godot OpenXR vendors plugin. So we just click on that and we say download. So this is the only plugin that we need. And the only thing that's really in this plugin, besides a little bit of logic for some of the specific vendor options, are all the loaders that we need. So this is one thing that I'm hoping is actually going to be a thing of the past eventually. So I just hit install there, and it says installed successfully. So now in our add-ons, we have our OpenXR vendors installed over there. I'm hoping that the loaders at some point will no longer be needed. Ignore, by the way, these errors in here. That's just a startup thing that happens the first time that you install it. That goes away by itself. But yeah, I am hoping that the loaders eventually will be solved and everybody will be using the same loader on Android, and we can just add that into the core application. But because everybody now, HTC is the only one that I know of that is using the core loaders. I think Qualcomm are, but with a footnote, because they do need some of the functionality that is in OpenXR 1.1. But Meta has their own loader, Pico has their own loader. So and we can't put those into the core because of ownership reasons and licensing reasons. So the next step for us is that we now need to configure an export to tell Godot what is actually that we need. Oh, look at that! I don't have that one. That's interesting. I will go to that in a second. But let's start set this up first. So we're going to call this Quest because we're going to set it up for Quest. And then going down this, the first thing that we need to do is we need to tick Gradle build. So this is all mentioned in that documentation page. So I don't care about any of these. I believe I can leave those all default, but I do need to set the XR mode to OpenXR. I need to make sure that in this case, because we're going to use the Quest, that we're going to enable the Meta plugin. And then all the way at the bottom, there are some extra Meta feature tags that we need. So we're not going to start with eye tracking or hand tracking, but if we want to use those things, we need to set them. I'm just going to preempt pass-through as optional because I do want to play around with that one. We can see that if we want to use the anchor or scene API, which isn't actually working in 4.2 because you need some extra logic that we added in 4.3. But you also need to give permissions for these things, and that bit we had already added. So that's why those two tick boxes are there. The rest we can just leave a default. So here we can mark which quests we support. That's really something that just is added into the manifest file to let Meta know, what our capabilities are. Godot supports all of them. Interesting enough, Meta made it so that if you want to support the Quest 1, you can't support the Quest 3. Or you can't support the Quest 3 in Quest 3 mode, I should say. It will still run on the Quest 3, but you're limited to backwards compatibility settings for the Quest 1. So this is also why the Quest 1 support is off by default, because we want to use the nice new features that the Quest 3 offers. It gives us a few little red things here that we need to solve. The first, very nice, there's actually a fixed import. It's just simply saying that by default, some of the texture compression options are off that we need to do turn on for Android. So that's there. The build templates, we downloaded them, but we haven't installed them in our project yet. So we'll fix that in a minute. And then it also is saying that our Android SDK path is not there, which I'm very surprised at because it's supposed to copy that over. So let's fix that one first. And I believe that is, no, that is not an editor settings. No, it is in editor settings. You can see that I haven't done this one for a while because normally it just takes that over from my last one. There you go. So we have our Java path set up nicely to open JDK 17. That is the other thing that is important here, which is a bit of a pain in the butt. Android is very peculiar, especially because we are still supporting some of the older Android phones, that you have to make sure that you have the exact correct version. So we have to use OpenJDK 17, and we have to have certain parts of, hold on, I'm just going to start, open up Android Studio because it's easier to find the path that way. We have to have certain things pre-installed in Android Studio, and that's actually a good reason to go in here. So if we open up Android Studio, we have a thing here called the SDK Manager. This is where we find the folder that we need. So let's just see if, no, I just want to copy that. Can I not? Oh, I can. So I'm just going to copy that and actually cancel out here. Just paste that in there. But the other thing is that if we go to SDK Tools, we have to have specific versions selected here. And to know which versions, we just go to this page here, and it will tell you exactly the versions that that we need. Oh, that's actually been updated, that we can use 305 or later now, not specifically that one. But yeah, always just double check here. That's where the biggest issues always come from when building things. That if you Android is supposed to download them for you. That's something that Gradle is supposed to do, but it's being very unreliable for some reason. So yeah, make sure that you're aware of that, that Android is properly set up. Anyway, this page also, this is actually, I just came here by on that deploying to Android page. There's an exporting for Android option here, and if you go there, you get that overview of everything that you need. There's also a nice command here to create your default debug key store. I've already created that, so I need to set that up here. Really surprised that I have to set those things up again. And now I need to remember where those are. That's a good question. Are they in my user folder? I don't want to create a new one. I'm guessing that's one. Let's hope that that is the correct one. We'll see if it likes that or not. So yeah, those are the things that we need to set up here in order to get that. I'm quite surprised that we actually had to do that today, that I didn't remember that from last time. Anyway, with that set up, the next thing that we need to do is just go to project here and go install Android build templates. And we're just going to hit install. All that does is from the templates that we downloaded, and we can't actually see that here. But if we go into our XR demo, we'll see that it creates this Android folder, and it actually creates our Android build files there. So it's just some stuff about how Godot works behind the scenes. So just following those instructions, everything is now in place. If we go back to export, we should see that all our red things have been removed. There is a yellow error warning here, which is actually complaining about, where are you? about this little thing here, if I remember correctly. Because it's actually going to insert the project name here. It actually already tells us that it's going to not, because it's taking the name of our project, and our project name is currently Godot XR Demo with spaces. Doesn't like the spaces, so it's just giving us a warning like, hey, I'm going to remove the spaces, make it small. If you want something different, then you need to change that. But it nicely does the rest for us, so we're going to leave that alone. With everything set up, with our quest running, now I do need to exit. I do need to quickly exit quest link. So disable quest link. There we go. Okay. I'm also quickly going to go to the Meta Developer Hub. Anybody who is not familiar enough with quests, I'd be surprised if the audience here. But if you're not using the Meta Developer Hub, you're missing out. Brilliant piece of software that they created. But I'm going to be using this really cool thing called Metacast, which allows me to, well, as I move my quest around, you can see what my quest is seeing. Nice funky little monitor thing there, because obviously I'm recording my monitor there. So with that running, I should be able to go in here. Note that I'm not using my play button this time, but I'm using this remote debug button, and I'm going to select Oculus Quest. The first time I do this, it's a lengthy process because it has to build the APK, or I think it's the APK that it builds here. Subsequent builds are going to be iterative builds, which means that obviously that's going to take a little less time. And that's the first time I've seen that one, but it seems to not care about that. So that's still running. So let's just wait until it actually goes through. It should eventually start up my little app here. I did that too quick, didn't I? So now we have it directly running on the Quest, and I'm just casting it. So I just wanted to show that, you know, running it on PC VR mode is really quick and simple. Running it on the Quest is a little bit more steps involved, with a few little hiccups that we just had. But it is all nicely documented here. But now that we do have it running on the Quest, we can do some fun things. Now, oh, the moment that I put my headset down, it just stopped the cast, didn't it? That's funny. Okay, so we have to start the cast every time. That's a bit annoying. Oh, hold on. I can change that. I can tell it. I don't care about the proximity sensor. So that's now disabled. So let's go here. Boom. Oh, and my Godot app still runs. So let's go and turn that off. So let's go quick. So yeah, that's a neat little feature to know about in Developer Hub, is that you can turn the proximity sensor off, and that means that even if I'm not wearing the headset and I'm not holding the little sensor, it will keep running and draining my battery. But for what we're doing right now, that is really good. So now we can keep casting, and I can keep looking at what that does. So the next thing that I want to do is double check in my project settings whether that's all good. That's all good. I don't need extra settings here, so that's cool. Because the next thing that I wanted to do here is to make sure that we are turning pass-through on, so that we can start looking at, okay, how would you start on a AR project? The first thing that I want to do is, in this case, I don't actually want my normal background. I will keep using my directional light so that I've got some lighting to show my little boxes. But I want to, in this case, change the background to just not show a sky. This is actually going to be not drawn, because we're going to be using a transparent background. So I might just put that a little bit up just so that I can see better. But the other thing that I want is I want a little bit of ambient light in here. Okay, that is because it's still on background. I just want to use color here. So Yeah, I'm just checking whether there's lighting on my hands, or else we're not going to see anything. So I'm just going to reconfigure my environment to not have a sky. I do want that. I am also quickly, just for the heck of it, no, I didn't want you there. I just want you here. I'm just going to add something on the floor so that we have something to see. So I'm just going to add a small plane mesh. I don't want that to be too big because that's going to look weird in VR, but I just want to have something that we can look down on and see if it's actually drawing that. Obviously, we're not doing any sort of occlusion at this point in time, but it's just a start. So we have all that in there, and I believe that there's only two things that we need to do here. The first is on our VP. We want to make sure that our background is transparent, or else that won't do anything. And the second thing that we want to do is on our XR interface, we want to call start passthrough. And in theory, that should be enough. Let me double check that we have that set in the export. I believe that we already did that. So yeah, we have passthrough and optional. That's really cool. Let's go and export that and go back to our casting. So obviously, wait until it actually starts our app. It's probably better to just wait here. Oh, look at that. Now we have our little dialogue there so that we can see once it's starting. And of course, it changes focus to there. Oh, I need to confirm my boundary. Why are you not remembering that we already had that? And now we can see that even though passthrough is on, we can move our controller around, and our box is nicely following it. And we have our start. And if you look down, we can see. I'm actually surprised that is. Oh, that's just yeah. That's just illusion. That is actually on the ground, but because obviously our passthrough is drawn on top of it, and we're not using any occlusion measures, that's looking a little bit weird. So I probably should have done something else. But yeah, that's really our start. That we now have passthrough on. We can see our objects. We could place things around our scene to have more things, but that's really where our starting point lies. If we want to do an AR application with Godot. Now, I just want to stress again that the next step that you would take here, where you would start using the scene API for Meta, that's all coming in 4.3. So there isn't a whole lot more that I can show specific to AR. But this is your starting point where you can do things. There's actually a couple of people who are already doing some cool things with this. There's someone in Germany, I believe he is, who actually made his own version of the scene API and allowing you to draw where your walls are and things like that, completely in Godot. And he has his application joined up to Google Home, I believe. So he walks around his home, and he can turn his lights on and off by pointing at things in AR while wearing a headset, and he can see information about all sorts of things. So that's a pretty cool little project that he's doing. But to really do that properly, you're obviously going to need the stuff that's coming in 4.3, where you get all the logic that is available in the scene API for Meta, and you can draw your things. So that is all the basic stuff that I wanted to cover today. So I don't know how we are on time. I could potentially also have a quick look at XR Tools, which will show that we have a whole bunch of standard features that we can just plop in and use, because obviously it's not interesting to just have boxes floating around. But I'm not sure how we are on time, and whether that is something that that we want to cover today, or if we should just open the floor to questions. And I can imagine that this is a big dump of information already.
We're fine on time. We still have more than half an hour left.
All right.
There's two questions on this part. Dylan asks if the depth API will be supported for occlusion.
Yes, eventually it will, but it will probably not make it into 4.3. That is on the list of things that that is being added, but I think that that's going to be a 4.4 feature. However, with the scene API and some other features that we have available in Godot 4.3. When you, for instance, have the scene API find out where your desk is or where your wall is, 4.3 has the ability to draw transparent geometry there and fill the depth buffer in that way. So it's not as good as using the Dev API directly, but it will allow you to do a lot of occlusion things. So that's one of the things where, unfortunately, I can't show the stuff yet that the guys who are doing the hackathon are working on, because they're making use of that that approach. So in 4.3, there will be options to do occlusion in that way, but the full Dev API support will probably be a 4.4 feature.
Okay. Wilco asked about AR support for other platforms, AR Core, AR Kit, and how complex it would be to support multiple platforms for AR developed in a single project.
Yeah, that's a good question, and that's a hard answer. We have rudimentary AR Kit support in Godot 3. That's actually where my AR journey started. However, that still needs to be ported to Godot 4. With AR Kit or AR Core has been a really rocky road. We had that working in test a couple of years ago, but ran into problems where the way that it was added into Core meant that every Android application was going to be an AR Core application, so that was a bit of a dead end. And redoing that as a plugin so that it became optional, we never fully got working, and that's just a matter of there just not being people within our community who have an interest and a pre-existing skill set in order to complete that logic. So that plugin has been at the 90% complete mark for a long time. The other option obviously is Tilt 5, and it's out of my reach, or else I would grab it. So like I said, Tilt 5 has got its own plugin. Now, as far as creating something that is portable between one platform and another, that lies a little bit in the middle, because that really depends on whether you're using any features that are specific to any given platform. So from a Godot point of view, it is a matter of instantiating the right interface. So you would instantiate the ARKit interface if you want to use ARKit, or you would instantiate the Tilt 5 interface if you want to use Tilt 5. But then we're still using the same core objects and the same core interfaces to make it work. So as long as you stay there, it is portable. But the moment, obviously, that you're going to use platform-specific logic, like for instance on a Tilt 5, that you can have up to 4 glasses connected to one PC, then obviously you start losing the ability to easily make your game work on multiple platforms. There are ways of doing it. You can. There's some really cool things around the export mechanism, where you can set extra flags that tell you, am I exporting for Tilt 5, or am I exporting for ARKit, or am I exporting for Quest? And you can use that to, to load in different scenes. Obviously, for our demo today, we have just been using one big scene, but one of the really cool things of Godot is, and I can really quickly show you that. So if I right-click on the XR origin here, for instance, and I do save branches scene, and I'm going to save that as the player scene, then now all of a sudden I have a scene with just all that stuff in there, and that's being referenced from our main scene. So from the Godot point of view, this is still exactly the same, but from an organizational point of view, I suddenly have all my player logic in a separate scene. Now, the next step from this is I could have a player scene for ARKit, I could have a player scene for Tilt 5, I could have a player scene for Quest with all the specific logic in there, or OpenXR, I should say. And I could change my main scene to load in the correct one for the platform that I'm on. So those are the ways that you can deal with platform differences. And switch between them and say, well, I'm going to just include this bit and have my platform specific code in this scene and there. So yeah, there is an amount of work that needs to be done by the user to make that possible. But Godot does support, if you're smart about what you do, does support the ability to deploy the same app to multiple different devices and cater to the device differences. But again, right now we are supporting OpenXR, we are supporting Tilt5 in Godot 4.3. Hopefully the ARKit logic will be ported at some point, but it's just not very high on the priority list at this point in time. I'm hoping that at some point in time we find a contributor who is willing to. Well, there are a couple of people who are willing to, but we need to still find someone who also has the background to actually complete the AR core thing. Although they're also. The big question is going to be what is happening on Google's side anyway. Google is obviously coming out with their Android XR. Is that going to change AR core? Are we going to have AR functionality through OpenXR maybe? I don't know. There's a whole bunch of options that might be on the table. One thing that we have been working on that is, it's probably not going to be making it in 4.3, but it will hopefully be in 4.4. Is that we're going to make sure that the different form factors work. Right now, head mounted, so that's your normal HMD devices. That works in OpenXR, but because there's no support for any handhelds, that currently isn't fully implemented. But if that comes to be, then doing phone-based AR through OpenXR hopefully at some point will be supported. But there's some other modes that are on the horizon. So. That's a bit of a maybe at this point in time.
Okay, and then Hizzy1 says he's positively surprised about the iteration speed, and he asks about support for HoloLens 2, and also if MRTK is going to be possible within Godot.
So HoloLens has been a really touchy subject for us, especially now that Microsoft has kind of taken a breather, or however you want to say it. The big problem that we had with Godot was twofold. One is that HoloLens requires DirectX support, and for the longest time, Godot didn't have native DirectX support. Now that is currently available in, I think it's been merged in 4.3. However, there's still some work to do to make DirectX render in stereo. There's still some issues with the multi-view support in the DirectX renderer. But once that is fixed, then that part should be solved. The other problem is that HoloLens requires to deploy under Universal Windows Platform. Now, Godot 3 had support of that because that was the only way that we could deploy on Xbox. But because Xbox now supports normal Windows 32 applications, that need is no longer there. So Godot 4.3 with the DirectX renderer runs on Xbox. And that is the main driving factor. There is just not enough need and drive out there for us to invest the time to make Universal Windows support work in Godot 4 when the only system that needs it is HoloLens 2, and HoloLens is basically end of life. So if someone wants to step up and take a look at the Universal Window Platform support that we have in Godot 3 and finish the porting of that to Godot 4, then in theory we have all the ingredients to run Godot on HoloLens. But if nobody steps up there, I don't think there's a driving force right now in the Godot community to actually make that happen. Especially if Microsoft is still active and really pushing HoloLens, then we would probably do it. But without that, it's really something that just it's not high enough on any priority list. As far as MRTK, that is up to the developers of MRTK, whether they are willing to look at Godot as a platform that they want to support. So yeah, it would be nice if we have more seasoned developers to port their toolkits over to Godot. I would love it, but yeah. So I hope that answers both questions.
I think so. Another question is about interactive stereoscopic video from Wouter. He says only the theoric codec is supported for video playback within Godot. And he wants plans for AV1 or other codecs.
So yeah, so yes and no, in the sense that there are a couple of people who are experimenting with stereo video in Godot and actually doing playback in VR. The problem again that we have in Godot is obviously licensing. The fact that we are an open source project, we only support video formats that are open. We do have a plugin system that allows people to embed proprietary video formats support in there, but I am not aware of anybody who is actively implementing that for things for like MP4 and that sort of thing. So I don't have much direct experience with that. I do know that Malcolm has a sample project on his GitHub where he is playing, and I'm trying to remember the open standard format that we're using there. I can't remember what the video format is that we support out of the box, but he's converted some video to that format and is then playing that on a video screen. And I think that we have an example where we're playing back a side-by-side video stream, and then making sure that one side is on the left eye, the other side is on the right eye, and you get basically a 3D TV sort of experience in Godot. So yeah, half. You can do it with Godot. The functionality is there. The missing ingredient is if you're using proprietary video formats, it's not supported in core. You have to find if someone's implemented a plugin that brings that format to Godot.
Okay. Let's see. Looking at the time, we've got roughly 20 minutes left. There's one thing I definitely want to ask you was the news item of a couple of weeks ago about more specific MetaQuest support in Godot together with Meta. Can you explain something about that? Give some details.
Give me 1 second because I suddenly remember if we are going to have a quick look at XR Tools. That one's a slightly bigger library, so I might as well just have that download running while we talk about that. So back to the asset library, I just search for XR Tools. We'll find it there, and we just hit download. And the download is pretty quick, but I believe that it needs to convert some things. So leave that running. And hopefully by the time that we finish talking about that, that will all be there and finished. Oh, it looks like we actually... I wasn't aware that we backported a few of those things to Godot 4.2.2 because that took a lot longer in 4.2.1. I know that there has been a lot of improvements in porting speed, but I thought that was only in 4.3. Anyway, sorry, I'm on a tangent now. So yeah, the news about Meta. So the story there is, first of all, that as I mentioned in my introduction or in my slides, Meta has supported the Godot Foundation directly, or back when we were still in the SFC, for 2 consecutive years, where they basically paid to allow me to do the whole OpenXR support in Godot. So that is all the core OpenXR support that we've done, basically everything that you've seen today. But because we're an open source foundation, we are limited to what we can do when it comes to proprietary or vendor-specific logic. We have a mandate that everything that we do from the core organization has as wide a reach as possible. So that was a bit of a problem for Meta, where they have their platform SDK, which is purely proprietary Meta, and then they have a number of vendor extensions like the Scene API that are kind of in a gray area where we might pick them up or we might not pick them up depending on what the abilities are. So Meta at that point in time decided that they wanted to fully fund that development and have that done by an organization that isn't constrained by the rules that the foundation plays under. So they started a contract with W4 Games. and that allowed W4 Games to hire a number of people within the Godot XR community, mainly David Snowpack, who has done all the WebXR support in core, and Logan, and I forgot his last name, including also a number of people on the meta side. So there's a couple of people, a couple of engineers on the meta side involved to also help out and do things. And they are currently focusing on building the logic that we as a foundation, can't do purely for the fact that we have this mission statement that we need to do things that are broad and not specific to one vendor. So that, as far as I'm aware, and obviously this is a contract between W4 Games and Meta. It is in the end between them, but everything that they're doing, they are upstreaming to either the vendor plugin or Godot itself, with the exception of the platform SDK. As far as I'm aware, that is going to be a separate plugin that is going to be downloadable from Meta's developer website. But as far as I've been told, that is going to be a free download. It's just going to be under their license. So just like right now, if you download the Unity SDK from their website, or the Unreal SDK, you have to tick that little tick box that you accept the license that Meta has on that thing. That will apply to the platform SDK plugin as well. And again, that's one of the reasons why we as the foundation have to keep our hands off of that. And that's fine. We're happy with that. That's just a way to the cookie crumble, so to speak. Same thing with console support, that is done by third parties as well. But again, it's between W4 Games and Meta what that relationship is and what the exact deal is. We are not privy to that. All I have been told, and that I know because I work very closely with most of these guys, is that those are the three areas that they're going to work on. They're currently, the first thing that they have priority for that they're working on is making sure that a number of the vendor-specific OpenXR APIs are taken care of. So that's why the Scene API is now done. That's why the Deft API is. I know that they're going to spend time on that. That's why they've done the body tracking and face tracking that Meta has available on the Quest Pro and Quest 3. The body tracking, I think, is on the Quest 3 as well. So that's what they're working on. That's their priority. That's why most of those things are ending up in 4.3. The second thing is optimizations in Godot itself. So they are working on a number of improvements to Godot for making Godot run better on the Quest. What that entails is something that we will find out the moment that those things are available. And the last priority that I'm aware of is then, like I said, the platform SDK, so that you have the whole store integration that we can we have access to all the proprietary bits of Meta. So that is what that deal is and what that encompasses. So there's a little bit of overlap with my work. And I'm involved there as the XR team leader, making sure that the things that are coming in and that are being done fit within the bigger picture, so to speak. But yeah, it's I'm very happy with that. It's really allowed for a lot of things to be done in record time that, as the foundation, we kind of couldn't prioritize. So it's a win-win for everyone involved. So it's really cool. So I hope that answers your question on that.
Yeah, definitely. Perfect. Okay, so we have 15 minutes left.
Well, for this little bit, I probably only need about 5 or 10 minutes, and then if there's any more questions coming, we can talk about that. I just wanted to give a quick introduction in our tools library called XR Tools. And this is way too big to deal with the whole thing. But I just wanted to show how some of the basics work. And I'm just going to go to our player rig that we set up here. So that's all standard out of the box. But what I can now start doing is I can use whatever I want from the toolbox. I don't have to use everything. There's a whole bunch of things in there that are really cool. But if I just want to do the basic thing, so let's say that I want to be able to move around in my world, I can simply grab my, where are you? too many things here. There it should be, because there's a lot of them here. I'm looking for just the direct movement. Here we go. So I can grab this scene called movement direct TSCN, and I can just drop it on my right hand, and it's there now. And in the same way, I can find my teleport. So there's a scene here called teleport. I can put that on my left hand. Now that actually shows us already that, hey, there's a teleport thing here. And in the same way, if I don't like my little boxes, I can go to hands here and scenes, and I just want to do the low poly versions, and I want to start with my left hand, and I just drag that in. Oops, it needs to be on there. That's I don't need to do that again because it's now on the wrong spot. Let's do that again and make sure that I drop it on there. There we go. I no longer need you. I suddenly have a hand there. Look at that. And that thing is going to work. And I'm going to do the same thing on the right hand. I'm just going to drop in my right hand there. So, and I did exactly the same mistake that I made with my left hand. That's interesting. I want to drop you on top of that node because it needs to be a child node there. So I just wanted to quickly show you that, that's how easy you can bring in functionality from one of these toolkits. You just drag the different objects in there. Now, in this case, this is all physics based. So we haven't got any physics set up right now, which would mean that if we run this, we actually fall through the non-existing floor and we keep falling. So I need to make a small change. I thought I'd save that. Scene, save, thank you. So I'm going to have to make this floor do a little bit more, and I'm just going to really quickly put in a static body here. And I'm just going to keep this little floor here so that it actually moves around. Also, before we do that, I just want to turn off my pass-through because I don't want to do that in pass-through. And for static bodies, Godot uses a split solution, where you have a single static body as like a physics container, but then you can have any number of collisions shapes that we add in. Now we need only one, which is going to be, in this case, a world boundary shape. That basically means that we have a infinitely sized ground plane that we cannot fall through. So that's a nice collision shape to use for the floor. So in theory, we should be able to move around our world now. That also means that I actually want to go back to having our sky. Look at that, our sky is back, because we're going to use our little thingy here as a reference. And I'm also going to go back into link mode, because that is just easier for this. So bear with me while I turn a link back on. Come on, yeah, there we go. Press link, launch. Sweet. And now I can just run that in normal mode. So we should get our little preview here. And I forgot a step. Nuts. What I forgot to do is go into project settings and then plugins, and I need to enable my Godot XR Tools plugin. Okay, don't know if I need to restart before that listens to it. Oh, that is, of course, because it's, there we go. So, yeah, I can move my hand now, and I can move my fingers. My right hand was for direct movement, so I should, oh, my joystick isn't working. Why is my joystick not working? And also, why is my, okay, that's interesting. Always fun when you do a hasty demo that we run into something. Is that just because that's still, that should be good now. Do I just need to reload? I might need to reload. Let's just do a quick reload of the current project. And also, why are you no longer good? Go back on, thank you. Am I still in? Yeah, that's good. Let's try it again. I don't have enough hands for this, but yeah, I can look around, I see my ground plane, I see him, and now I can move around. So I'm using my joystick to move around my world. I didn't enable turning, which is a bit dumb of me, so I can only move forward and backwards. And if I just move this into my other hand and take my left hand and use that guy, you can see that there is a little teleport thingy that starts, and I can turn around while I teleport. So all of a sudden, just by dragging those things in from the XR Tools plugin, I suddenly have all that logic, working out of the box. And that's really how easy you can build a VR application from XR Tools. It's just a matter of, you obviously do need to know what all the different components are, but there's a whole bunch of tutorials and both as videos and written tutorials that walk through most of the features that we have added into XR Tools. And this is a really complete project. The other option that is noteworthy here is Godot XR Tools lives on GitHub. It's, again, fully open source. But on the GitHub, there's actually a whole demo included. And this demo that's on there, I don't know if we don't have a screenshot, that's a shame. This demo that is included on the XR Tool website shows off every little bit. So yeah, we have, we've got a demo for audio stuff. We have, basically what I just did, the basic movement. We have climbing, and you can glide. This is, I think, another audio demo that we have. We have a grapple, so you can be Spider-Man if you want. Interactables is where you can pick things up and how that all works. The main menu is the thing that we start in that allows you to select all the demos. We have a really cool demo where you're actually on a sphere, and you can, it's kind of like Mario Galaxy, but then in VR. Interactables is where you can move things and use joysticks and buttons and all that sort of stuff. The pickable demo is the one where you can pick up objects and you can throw an axe, and is an axe or a hammer? I think it's a hammer that you can throw. Pointer demo is our UI demo, so where you can interact with with a 2D UI and click on buttons and type in text and all that sort of stuff. UK cat. My cat's making a whole lot of noise in the background. Poke demo is something where you can move things around by touching them with your hands. I might have mixed up sphere demo or origin demo and sphere demo. Not quite sure what the difference between those two is. But anyway, there's a whole bunch of demos in there. This one was actually this is our version of Gorilla Tag, where you can move around like with your hands, like in Gorilla Tag. So yeah, there's a whole bunch of examples in the demo application. If you on the releases here, I believe we just have a download for it. So on our releases, you can actually download the demo project as is, and that has everything included. So you can just extract that, open it up in Godot, and run it. So it's a fun little thing to use. So really, that was all that I wanted to quickly show about XR Tools. Obviously, I could talk for hours and hours showing everything off. We could, fire up the demo and show every little bit and how it works. Again, this is very VR oriented, so to build VR games, although there are a number of things like the picking up and that sort of stuff that obviously also applies to AR projects, but it's still very VR oriented. So I wasn't sure how much of the XR Tools apply to the interest of the current audience that we have. So I think that is it as far as what I wanted to do presentation wise. So I will stop sharing so that I can also see the chat. I'm not sure where we were left over. So I'll leave the floor to you guys. I can stay online for as long as you guys want to ask questions. So I'm more than happy to answer whatever else is left to be answered.
Yeah, first let me say very much a thank you. Great demonstration, great overview of Godot. Judging by all the comments that I see, people are quite impressed by the possibilities, the speed, and well, seems to be turning into a good alternative to the commercial engines. It's fine if we stay online just for the people that need to go at 12. Thank you very much for attending. I will try to make a little write-up of this session, including the recording, and put it on the innovation forum. Yeah, and if there's any questions, please either raise your hand or put them in the chat. By the way, I thought it was pretty gutsy of you to do a live demo like this, including development.
Well, this is not the first one that I've done, but it is always, especially because I downloaded 422, which came out this week, just prior to this demo. That was actually the biggest risk. I wasn't sure if there were any regressions in this build. See, it was only just released, but it worked actually better than. Yeah, I'm very surprised to find out that some of the things that I thought was only going to be in 4.3 were actually backported to 4.2. So especially the loading speed was usually the in 4.2.1, if you download XR Tools, you're sitting there for a good minute for it to load the first time. And you could see it was. I was surprised that I wanted to wait that minute while we were answering some questions, and it's already finished. So yeah, very happy about that. Yeah, other than that, I think the big takeaway that I do want to make sure that everybody's aware of is, Godot is a FOSS project. The bigger the community becomes, the more will become available and the faster we go. But we're still, development-wise, in that way, we are behind, obviously, the big ones because we haven't had millions of dollars invested in, really cool interaction plugins and libraries and whatnot. But even that said, the amount of work that we have done and the amount of stuff that is there, I'm very proud of how far we are and what we have available. And especially something like XR Tools, if you want to make a VR game, you really have all the components there, and it's really up to you to then make something out of that. And that also shows in the caliber of people that we have in our community. We have everybody from very experienced VR developers who are switching over from Unity to people who've never touched XR in their lives and are building stuff with it. So it's really cool to see that, and that is, I think, a testament to that we have all the foundation there. And the other thing, of course, is because it's open source, not just Godot, but also XR Tools being open source, it means that if something doesn't work up to your expectations, you can use 90% of XR Tools and then add the 10% that you think needs to be different, and you can customize it to your heart's content. And that's I think very unique to Godot and the philosophy behind Godot.
All right. Okay. Once more, thank you, everyone. Bastiaan and me will stay around just in case there's more questions. But to everybody else, thanks for joining, and hope to see you in the next either developer networking meeting or at the National XR Day in a couple of weeks. Cool. And with that. So
Wilco, that's a good question. Multiplayer experiences is that is a touchy subject in the sense that Godot has recently, and with recently I mean that it was added in, I think in 4.2, gotten a really nice multiplayer layer embedded. And on top of that, W4 Games has made actually a whole game server solution that you don't have to use, but you can use, but just as a testament of what it can do. However, the problem that we have with VR is that the way that you control your character and the amount of data that you get from your tracking and being able to correctly replicate that over the network requires you to take a couple of extra steps. And the people who just grab the tutorials that are out there for the multiplayer solution and just take the normal game approach and just plunk that into an XR application, they hit a brick wall really quickly. So the initial experience of a lot of people is suddenly like, oh, this isn't working. However, if you take the time to really figure out how it's designed and how it works, and you do it the right way, and the right way currently isn't really documented very well yet, it actually works really good. And Malcolm has a couple of test projects out there now because he's sort of taken aboard a lot of the feedback and sort of went like, okay, I want to try if I can make this work the way that it should. And he has a multiplayer demo currently with all the basics working. But it's really one of those areas where Godot has the functionality, it can do it really well, but it's so new that there isn't there aren't enough resources to help you actually get there. That's really the message that I want to give there. And the documentation that is there sets you on the wrong foot. So, you know, depends a little bit on how much effort you want to put in there, and trying to sort of, you know, use something that's so brand new that there isn't enough documentation to help you, and you need to ask a lot of questions. Then you'll get there. A couple of months from now, when more and more people have done that, and those things are there, then obviously that's going to change. So functionality is there. It's just the how-tos are still missing.
Is there a public roadmap available, or is that something that develops step by step?
That is actually something that is under heavy discussion. We are trying to put a global roadmap together for ourselves, and that is something that is under you know, sort of under development. We have specifically for XR, we have bi-weekly meetings where we will talk about the things that are being worked on. The thing where we're hesitant is just past experience as an open source project, because we are so dependent on people volunteering their time, and you know, people get job offers that suddenly disappear, or you know, things don't work out, and something gets dropped. We have very bad experiences in the past where we are too public with what we are planning, is that people take it as, oh, but you promised that, you know, 6 months from now this will be there. And yeah, well, in those 6 months we lost a contributor who you know, who was you know, hired by some company, or who had another reason that he or she you know, can't contribute anymore. Or, you know, I've been in the position a number of times now where we had a great idea and we tried to implement it and it just didn't work, and we had to go back to the drawing board. And that's the downside of open source. You know, a normal company would do that all internally, right? They wouldn't hang out their dirty laundry. They're not going to give you something on the roadmap until they're sure that they're going to deliver. But with an open source organization that's doing everything public, that's impossible. And yeah, we've been bitten too many times. So we're very careful with setting out roadmaps. You know, we do the blog posts where we sort of let people know what we're working on and what we think is going to be available in the short term. But we're very careful nowadays to make long-term promises, simply because of, you know, the sort of organization that we are.
Makes sense. Yep. Any more questions from the group that's still left, the survivors?
Yeah. Oh.
And if not, we can stop at this point.
Yeah. No, it's you know, it's been a fun session. Thanks for inviting me.
Yeah.
Thanks for all you know, all the questions and all the feedback, and you know, I'm glad people enjoyed seeing what I had to show. You know, I know it was all a bit of a crash course, and there's only so much you can do in an hour's time. But I hope everybody got a good idea of what Godot can do. WebXR support, so that's David Snowpack who works on there. We have most of the basic functionality. I think that just about everything in XR Tools works both in WebXR and in OpenXR. So one of the things that I didn't show today is if you use the startup script that comes with XR Tools, you will actually get bonus WebXR support in your project. You just need to set up the exports, and as long as you stick with all the XR Tools components, you will have an OpenXR application that you can also deploy to WebXR. That said, obviously deploying over the web does have a significant performance cost. So there are limits to what you can do. One other thing which might be interesting, just to So we did a game jam. The first one we did last December. We're gonna probably plan another one either mid-June or early July. But if we go to the submissions here, First of all, these are a lot of really nice little projects to try out, but there's a bunch of them that are actually web-based. So I believe, where are you? Why can't I see it? Where's? Oh, that's the cast. Here, David Snowbeck. So this one is definitely one that runs in WebXR because that is made by David Snowbeck. So he wanted to show a WebXR implementation, and a lot of these are actually open source as well. So it's quite nice to have a look at. But yeah, so yeah, WebXR support is in a pretty decent state. Obviously, OpenXR is our priority, so things generally come first to OpenXR. And later to, so like, we have had hand tracking support in OpenXR for well over a year. We only have had it in WebXR for the last couple of months, and it's in 4.3, so it's not even available in 4.2. But yeah, so it is still a pretty decently complete implementation of WebXR. So yeah, cool stuff.
Okay, I think the thing you just looked up, but we can't see your screen, so we not exactly.
Oh, sorry about that. That's right. I obviously am not. So I'm just going to go and hold on for a sec. No, that's the wrong place. Here we go. I'm just going to paste that link in the chat. That's much easier. I forgot that I had already shut down the screen sharing. So yeah, so that's the link to the last jam that we did and all the entries. And the one that I was talking about is the Cloud Commander VR game by David Snowbeck. That one I know is WebXR, but I believe that there's a few others that were made with XR Tools, and therefore also have XR support. I do believe you need to enable it if you want to use it. But it does come with the XR Tools library. So yeah, basically it should just be cross-platform between OpenXR and WebXR for the most part.
Is that the same game jam where you went through all the entries in your live stream?
Yeah,
I thought it was really funny to see you try them out and have weird experiences.
Yeah, so some of them worked really well. Others were very confusing. Some, and that's always the risk with game jams, especially a 2-day game jam. That was the biggest thing that we learned. 2 days is not enough. It's not enough to add the polish that you need. A good example for that is the My Stupid Death in a Sauna by Rodzilla, which I thought was really cool because Rodzilla is one of the Godot developers who made Material Maker. So he's a very skilled developer. He'd never done something in XR. This was his first project in XR, and it is actually a really nice little game, but he just missed that little bit of time to polish it up and to so if you get stuck in that game, it's like an escape room thing. So if you get stuck, you're stuck, and you're not going to figure out how to get out there because there just aren't enough hints to get you over the hurdle. And that obviously, you don't get that unless you have some time to do some play testing and get some feedback and do some stuff with it. But there are some really cool entries in there. I was very surprised with what was created and how much people figured out in 2 days time. So the next one we're planning to do a whole week and give people some proper time to put something together. But I'm running late in actually organizing it. I really need to get it together. So yeah, we're probably going to announce the next one pretty soon.
All right. Okay, I suggest we end it here due to time as well, and we've taken a lot of your time.
That's all right.
Very much.
All right. Thank you for having me. It was a lot of fun. I enjoyed this. So.
Okay. Hey, perfect. Hope to talk to you later.
All right. No worries. All right. Bye, everybody.
Bye-bye.